This is like looking at finding tangents and normals to a curve. We're looking at any curve here to do with exponentials, logs, and trig functions. So finding the gradient of a tangent or a normal, we'll look at that first. Then the first thing you need to do is you need to find the first derivative. And if we're doing it at the point, let's just say when x equals a, and we're looking at the curve y equals f of x, then you find the first derivative, which is f dash x, and the gradient of the tangent will then equal f dash, and you have to sub in the value of a, and that will give you the gradient of the tangent. But if you want the gradient of the normal, then that's going to be minus 1 over the gradient of the tangent. Okay, so you flip it and you change its sign. If you want the actual equation of the tangent, then you also need a point. So you need the gradient and the point. And then you use y minus y1 equals mx minus x1. So if you haven't got a point already, you get your x equals a and you put it into the original function and find f of a. Then it's y minus the y value, which is f of a, equals the gradient of the tangent, x minus a. So you just put it into that formula and into that equation. If it was for the normal, it'd be y minus f of a, and the only difference is you put minus 1 over the gradient of the tangent, so you do the perpendicular gradient. Okay, so it's going to look at finding the equations of tangents and normals. I have an example here. So we're going to find the equation to y equals e to the minus 3x at x equals 2. So step 1 is to find the gradient. So the gradient is y dash. So because it's an exponential, you write it, derive it, you get minus 3ex to the minus 3x. So we want the gradient at the particular point x equals 2. So y dash is minus 3x to the minus 3 times 2. So where the x is, you just put the 2, minus 3x to the minus 6, minus 3 over e to the 6. So that's the gradient at x equals 2. So the gradient is minus 3 over e to the 6. Okay, now we have the curve y equals e to the minus 3x, and at the point where x equals 2, we need to find a point. Because if you want to find the equation of the tangent, you need the gradient, but you also need a point that it goes through. So if you put x equals 2 in, you put it into the original function, y equals e to the minus 3x, and so it's minus 3 times 2, so y equals e to the minus 6. So that's 1 over e to the 6. So we have a point, 2, 1 over e to the 6. We have a gradient, minus 3 over e to the 6. So the point, 2, 1 over e to the 6, and the gradient, 3 over e to the 6, with a minus. So the equation is y minus y1 equals mx minus x1. But y minus y1 is 1 over e to the 6. What's this here? That is. And then you go equals m. Now m is minus 3 over e to the 6. So there's your m. We put the m in place. And then it's x minus x1, which is 2. So there's your 2. You plug your 2 in. Now we just need to simplify this. Now see the e to the 6 there? I'm going to multiply that on that side, because that will just help to get it into a nice form. General form is like quite a nice form to put it in. So when you multiply that, you get e to the 6y minus, now e to the 6 times minus 1 on e to the 6 will be 1. Because it's like e to the 6 times 1 on e to the 6. So it's e to the 6 on e to the 6. So they'll cancel that and give 1. Well, that goes into that once. Equals the other ones, minus 3x, and then plus 6. So so if you bring it all to one side, you get 3x plus e to the 6y minus 1 minus 6 equals 0, which is 3x plus e to the 6y minus 7 equals 0. And that's the equation of the tangent. I'm going to look at a trig example. So we're going to find the equation of the normal to the curve. So that's y equals cos 2x, and we want it at x equals pi on 6. To differentiate, and cos 2x will go to minus sine 2x times 2, because you're timesing the derivative of the inside, so that's minus 2 sine 2x. At x equals pi on 6, y dash is minus 2 sine 2 pi on 6. Y dash is minus 2 sine, they cancel, you get pi on 3 sine 60, which is minus 2. Now sine 60, if we think about your triangle, there's 60, root 3, 1, 2. So sine 60 is root 3 on 2, so that's equal to minus root 3. So the gradient is minus root 3. So that is the gradient of the tangent. So the gradient of the normal would be the negative reciprocal of that, so the minus has to go to a plus, and the root 3 on 1 goes to 1 on root 3. So that's the gradient of the normal. We also need a point. Okay, so if we put in x equals pi on 6, y is cos 2 pi on 6, which leaves you with pi on 3, which is cos 60, so that's a half. So you go y minus a half, so it's the y value, equals 1 on root 3, this is the normal, x minus pi on 6. Multiply both sides by 2 root 3 to get rid of the fraction. So I might just do by root 3 first. Root 3y minus a half equals 1 x minus pi on 6. So that's root 3y minus root 3 on 2 equals x minus pi on 6. If I now multiply by 6, all the way along, the 2 will go into the 6 here and leave you with 3, and the 6's will go out there. So you get 6 root 3y, 2 goes into the 6, 3, so that's 3 root 3 equals x minus, the 6's cancel and you get pi. So you get x minus 6 root 3y plus 3 root 3 minus pi equals 0. And that's the equation of the normal. Okay, so we're just going to do another tangent one. So find the equation of the tangent to y equals ln x squared plus 1, and we want it at the x where x equals 1. So y dash would be f dash x on f of x. So the derivative of x squared plus 1, which is 2x, and over x squared plus 1. So if we did that at x equals 1, y dash is 2 times 1 on 1 squared plus 1, which is 2 on 2, which is 1. So the gradient of the tangent is 1. Then we want a point. So x equals 1, y is ln 1 squared plus 1, so y is ln 2. So we have a point, 1 ln 2, and we have a gradient, 1. So y minus y1, so that's ln 2, equals 1 x minus 1, y minus ln 2 equals x minus 1, and you expand that, bring it to that side, x minus y minus 1 plus ln 2 equals 0. And that is the equation of a tangent. Okay, so look at another, this is another normal one, so the equation of the normal to this one, and we wanted at x equals ln 2, so find the gradient, so that's 2e to the 2x, because it's write it, derive it, and the derivative of 2x is 2. At x equals ln 2, so y dash is 2e to ln 2. You can put this in your calculator, but just looking at this, that's e to the ln 2 squared, which is 2e to the ln 4. And e to the ln 4, the e and the ln, it's kind of like their reverse operations, they cancel each other out, so you get 8. Because e to the ln a is just a. That's why I had to move the 2 up here, because that just means that you get it into that form. Okay, so when x equals ln 2, y would be e to the 2 ln 2, which is e to the ln 2 squared, which is e to the ln 4, so that's just 4. So we have our point, ln 2 and 4, and we have our gradient. Now our gradient of a tangent is 8, so the normal is 1 on 8. So you go y minus 4 equals minus 1 on 8, x minus ln 2. So multiplying on the other side, 8y minus 32 equals minus x plus ln 2. Because you times the minus 1 in there, and you put the 8 up there. Just in case that was a little quick, let's go through it again. So you go 8y minus 4 equals minus 1 x minus ln 2. 8y minus 32 equals minus x plus ln 2. Bring that to that side, you get x plus 8y minus 32 minus ln 2 equals 0. And that is the equation of them.